Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over more problems on how to solve word problems using your conversion factors. So let's get into this. So number one, if a person is exercising enough to breathe in an average of 103.5 liters of air per minute, what total volume of air in liters is breathed in exactly 1 hour of exercise? So whenever you're attacking these sorts of word problems, you first want, there's two things. First, pull out the conversion factors, find the relationships. If you have something per something, that's a relationship, and you can use that as a conversion factor. So that's really important to pull out the conversion factors, so that way that's going to help you. You have tools to help you convert from one thing to the other. Which brings me to the second point. Second point number two is that you need to figure out where to begin and where to end in the problem. And that's where 99% of the time you're going to find it in the question. So the beginning of the question tells you the end of the problem. And then usually somewhere else in the question is going to be your starting point. Not always, but usually. So let's look at our first problem here. So we're told if a person is exercising enough to breathe in an average of 103.5 liters of air per minute, this is going to be a relationship. We got 103.5 liters of air per minute. So every minute they're breathing in air. So that amount is 103.5 liters of air is breathed in per minute. So that's a conversion factor we could possibly use. That's the only one that I see. And then, so now we have to figure out where to begin, where to end, and that's in the question. So the question is, what total volume of air in liters? The beginning of the question is the end of the problem. We want to find liters of air breathed in. So liters breathed in, liters of air. And if we keep reading, it tells us where to begin. It says, in exactly 1 hour of exercise. So notice the 1 hour is not tied to anything. It's not related to anything. It's just standing by itself. So that's a good indicator that that's what we're going to begin with. So let's begin with 1 hour of exercise. So we're going to have 1 hour over 1. And we got time. We have an hour of time. We want to convert that to something else. So here we have this relationship between liters of air per minute of time. So if we could convert hour to minutes, we could then use that conversion factor to help convert minutes to liters of air. So let's go ahead and do that. So we're going to convert hours to minutes. So 1 hour is on the bottom to cancel out with hours on top, and that's going to be 60 minutes on top here. So hours cancel out. Now we have minutes. So now we can use the 103.5 liters of air per minute as a conversion factor. So since we have minutes on top, we want minutes on the bottom. Well, per minute means 1 minute. So we're going to put 1 minute on the bottom and 103.5 liters of air. So 103.5 liters of air goes on top. So now minutes cancels out. Now we have liters of air. And guess what? They want to know what the total volume of air in liters that's breathed in. We have liters of air. We're done. So now all we need to do is multiply by everything on the top, divide by everything on the bottom. It's just 1. And so we get our answer. And when we calculate that out, we get 6.210. 6.210 times 10 to the third liters of air. Now let's look at our sig figs. So remember, when you're trying to determine the number of sig figs in your answer, the rule is when you're multiplying and dividing, your answer should have the same number of significant figures as the least number of significant figures in your measurements. Now, we're going to ignore the exact ones though. So here we're told that it's exactly 1 hour. So we're going to ignore the sig figs there because that's infinite. This is an exact relationship, so we're going to ignore that. So the only other value we have is the measurement 103.5 liters of air per minute. So that's 4 sig figs. So our answer should have 4 sig figs. And that's what we have. So we're done with this problem. Okay. Next, number 2. If a person has 4.83 liters of blood and 4.650 milligrams of amino acids per 100 milliliters of blood, how many grams of amino acids does the blood contain? So again, part 1, we're going to pull out the information that we need, or like things like conversion factors. So what do we have here that's a relationship? Well, we have, if a person has 4.83 liters of blood, that doesn't seem to be connected with anything. So we'll come back to that. Here we have 4.650 milligrams of amino acids per 100 milliliters of blood. They're related by each other. Something per something is a relationship. So that is going to be a conversion factor that we could possibly use. So 4.650 milligrams of amino acids per 100 milliliters of blood. Okay, now we get to the question. So remember, we need to figure out where to begin and where to end. The beginning of the beginning of the question is the end of the problem. So what's the beginning of the question? How many grams of amino acids? So we want grams of amino acids. That's our goal. What are we going to start with though? You'll notice here, there's nothing left in the question that's relevant. So how many grams of amino acids does the blood contain? Well, what blood? This amount of blood. So this is what we're going to start with. So notice this stands alone. It's not tied to anything. So, and it does reference, does the blood contain? Well, what blood? This blood. So we got to start with that. We're going to convert this amount of blood into grams of amino acids. So let's go ahead and get started. So we're going to start with 4.650 milligrams of amino acids. I'm going to say AA for amino acids over 1. And then we're going to start using conversion factors. Now, here I have milligrams of amino acids related to, what am I talking about here? It's not milligrams of amino acids. We're talking about liters of blood here. Okay, sorry about that. Liters of blood. I got discombobulated. That's pounds. Oh my gosh. Blood. Okay, so now that I got everything figured out. So now here we have milligrams of amino acids related to 100 milliliters of blood. We have milliliters, but we have liters. So if I could convert this to milliliters, then I can use this relationship as a conversion factor to convert to milligrams. Okay, so I know that 1 liter is equal to 1,000 milligrams, and I also know that 1 milligram, milli is 1/1000th, right? So 1 milligram is the same as 1/1000th of a gram, or 10 to the negative 3 grams. So I'm going to go ahead and do that. So here we're talking about liters though, so it's same with liters. So here we have 1, or 10, I should say, 10 to the negative 3 liters, or 1/1000th of a liter, is equal to 1 milliliter. And again, I could have easily used 1 liter is equal to 1,000 milliliters, or 10 to the 3 liters. It's the same relationship, so it works either way. Now, this is blood. We should identify what we're talking about. Blood. So liters of blood cancels out. Now we have milliliters of blood. Here now we have 100 milliliters of blood is going to give us 4.650 milligrams of amino acids. So let's set that up as a conversion factor. So since I have milliliters of blood on the top, I'm going to put 100 milliliters of blood on the bottom. And I'm going to put the 4.650 grams of amino acids on top, or milligrams of amino acids on top. So again, AA for amino acids. Now that I have that, milligrams of blood will cancel out. I have milligrams. What are they asking for? Grams. So again, milli, right? I can relate milligrams and grams. So 1 milligram is 1/1000th of a gram, or 10 to the negative 3 grams. I could use that as a conversion factor. Or you could say 1 gram is 1,000 milligrams. Either way is fine. I like going with 1 milligram because that's just the way I roll. So here, milligrams, 1 milligram of amino acids goes on top, and then 10 to the negative 3 grams of amino acids goes on. Did I say top? Milligrams is on the bottom, grams is on top. So milligrams of amino acids cancels out. And now I have grams of amino acids. So I'm done. So now all I need to do is multiply across top, divide by what's on the bottom, and I get my answer. And when I do that, I get 0.2246. So I don't have, I'll write it over here. So 0.2246, and that's going to be grams of amino acids. Now let's double check our sig figs here. So remember, when we're multiplying and dividing, the number of sig figs in our answer should be the same as the least number of sig figs in our measurements. So we're going to ignore the exact. So here we have 4 sig figs. This is exact, so we're going to ignore that. Here we have 4 sig figs. Here we have 3 sig figs. So 3 is the smallest number of sig figs. So keeping in mind, here we have 4. So we got 1, 2, 3. We're going to have to cut it off after the 4. And so notice this is a 6. So we're going to have to round the 4 to a 5. So then the final answer is going to be 0, or I'll just erase it here. So it's going to be 0.225 grams of amino acids. Okay, so far so good. Last problem. In optimum conditions, 1 molecule of the enzyme fumarase can convert 8 times 10 to the second molecules per minute of fumarate to malate. So basically, if I was to simplify or clarify what this is saying 1 enzyme molecule of fumarase can convert 8 times 10 to the 2 molecules of fumarate into malate per minute. So in 1 minute. Okay, so what is the information we're given here? So we're given 1 molecule of enzyme fumarase can convert 8 times 10 to the 2 molecules per minute. So this many molecules of fumarate can be converted into malate in 1 minute. So that is a relationship, that's a conversion factor that we could possibly use. And so that's it for at least the conversion factors or relationships. I don't see any others. Now we're at the question. Where do we begin and where do we end? So let's go to the question. Remember, the beginning of the question is the end of the problem. What is the beginning of the question? How many molecules of fumarate? So molecules of fumarate, that's how many. We want to know what the number of molecules of fumarate that can be converted by one of the enzymes molecules in 23 days. Well, the 23 days is what we need to begin with, right? So in this case, notice that 23 days is not tied to anything. It's not related to anything. It's just a standalone piece of information. And that indicates that this is where we're going to begin. So 23 days. So we're going to begin with 23 days over 1. And we want to multiply by conversion factors to get to the number of molecules of fumarate that is converted by the fumarase in this amount of time. So we got time here. We have a relationship of 800 molecules per minute. We got minutes. So if we could convert this to minutes, then we could use this relationship to convert to molecules. So let's go ahead and do that. So I have days on top. I know that 1 day is 24 hours. So days cancels out. Now I have hours. I know that 1 hour is 60 minutes. So I'm going to use that. So 1 hour on the bottom to cancel out and 60 minutes on top. So hours cancels out. Now I have minutes. Now I can use this relationship. So I know that 8 times 10 to the second molecules per minute. Minutes is going to go on the bottom because I want it to cancel out. So 1 minute on the bottom, and then the 8 times 10 to the second molecules. I'll just put molic for molecules. Minutes cancels out. Now I have molecules of fumarase or fumarate. That's what they want. I want to find the molecules of fumarate. I now have molecules of fumarate on top. I am done. So now all I need to do is multiply across the top, divide by the bottom, and I get my answer. And when I do that, my answer is 3 times 10 to the 7 molecules of the fumarate. So let me double check, make sure I didn't rewrite mistake. So yeah, 3 times 10 to the 7 molecules. Now, sig figs. Why do I only have one decimal? Why do I only have one sig fig here? Remember the rule. When you're multiplying and dividing, the number of sig figs in your answer should equal the number of sig figs in the least number of sig figs in your measurements. So here we have 23 days. That would be an exact number because we count days. We don't really measure days, but I guess we could measure days. So we could use that as a measurement. Even so, that would be 2 sig figs. 1 day, 24 hours, that's exact relationship, so we can ignore that. 1 hour is equal to 60 minutes, that's exact. This is not exact. This is a measurement, so we have 8 times 10 to the second. The great thing about scientific notation is that the scientific notation already gives you the number of the number of sig figs of the number of the measurement. So this number here in front, any digit that's in front here, even if it's a 0, it's going to be significant. So here we only have one significant figure. So that's the least number of sig figs. So we have 1 and we have 2. So 1 is less than 2. So our answer should only have one sig fig. So we only have one digit in front. And so that is our final answer. I hope this was helpful. If you enjoyed this video, if you learned a lot from this video, then by all means, please like the video. Hit that like button. Share the video with your friends. Make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, or if you have a topic you want me to cover, please put that down below so I can do that for you. I would love to do that for you. Thanks for joining me and have a great day.